In this presentation, we're going to look at sample size estimation for use in confidence intervals. So, an employment survey is carried out in order to determine the percentage P of unemployed people in a certain population in a way such that the estimation has a margin of error of less than 0.5%, half a percent, with a probability of at least 0.95. In a similar study conducted a few years ago, it was found that the percentage of unemployed people in the population was 6%. So we're going to use this later on. Okay. So estimate the sample size n that is required to achieve this margin of error by constructing an appropriate confidence interval or otherwise. So we're going to use it by constructing a confidence interval. So the 95% confidence interval for the population percentage P is given as follows: P hat plus or minus 1.96, where that is the quantile for 95% for confidence intervals, times the standard error. And here the standard error is P hat, the square root of P hat times 1 minus P hat all over n. So collectively we would call this the margin of error. Okay, so the margin of error is made up of the quantile and the standard error. Okay, so essentially what we're going to do here is rearrange that expression, and because we have a plus or minus there, plus or minus here, okay, essentially what we're going to do there is use the absolute value signs. P minus P hat, that is the true value and the sample estimate, and essentially the difference between the two is our margin of error, and that has to be less than 1.96 times the standard error. So essentially what we have to do here is rearrange this part here mathematically. Okay, so we want this difference, this margin of error, to be greater than 0.005, half a percent. Okay, so what we're going to do here is find the value of n that gives us that. So 0.005 equals 1.96 times the square root of the standard p hat times 1 minus p hat over n. Now, essentially what we have to do here is some quick algebraic rearrangement. Because we're squaring things, you know, we will get 1.96 squared times p hat 1 minus p hat over 0.005 to be squared. Okay, so a little bit of work goes into that there. These sample size estimations can be a little bit clunky to work with. Essentially what we have to do is find a value for n that would work there. Okay, so in a similar study, this is what we were told in the question. In a similar study conducted a year ago, it was found that the percentage of unemployed people was 6%. So this is the value of p hat that we're going to use in this expression to progress things further. If we were not, we would use 50%, 0.50. So essentially what we're given is some prior information that we can work with to make a valid estimate. If we were not given any value, we would use 0.50. Using the percentage from the previous study as the value for p hat, i.e. p hat equals 0.06, we would get approximately, depending on how you are working with your rounding error, 8,666. Actually, that should be 8,665. Let's look at it exactly there. So, using the expression we had before and using 0.6 as our value, we would get 1.96 squared, and that turns out to be 3.841, times 0.6 times 1 minus 0.6, that works out to be 0.0564. 0.5 squared works out to be 0.000025. Okay, so quite a bit of number crunching to do, but essentially what happens when we have the margin of this part here, the standard error, when we calculate the standard error out, we get 2256, and when we multiply that by 1.96 squared, which is 3.841, we get this value here, 8665.296, which is approximately, I didn't mean to put in that 0.6 there, which is approximately 8,666 people. Okay, so something I should just add there is that when you get a number like that, particularly with sample size estimation, you round it up. So even if it's 2.96 and you might sort of think to round it down, the correct thing to do is round it up, in this case to 8,666. So always round it up. Okay.